Hi all, welcome back to a discussion on magnetic field and matter. In this small video, I am going to discuss linear media and nonlinear media. Okay, now basically at the beginning of this chapter, we have classified the material into three categories based on its response to the magnetic field, the external magnetic field. And they are paramagnet, diamagnet, and ferromagnets. Okay. Now, the paramagnetism and diamagnetism would be present only in the presence of the external magnetic field, whereas a ferromagnetic property can be there even in the absence of the external magnetic field. Okay, so if you look at the paramagnetism or diamagnetism, so this response would be absent if there is no external field. Okay, now how we measure the response? So this response of this paramagnetism and diamagnetism would be measured in terms of magnetization. Okay, in case of paramagnetism, the magnetization will have magnetization in the direction of the applied field, and for diamagnetism, the magnetization would be opposite the applied field. So for paramagnetism, magnetization would be along the direction of applied field, and for diamagnetisation or diamagnetic material, the magnetization would be opposite to applied field. Okay, now suppose if the applied field is very weak. If the applied field is very weak, then this magnetization would be directly proportional to the strength of the applied field. Okay, so the magnetization M, you can write this magnetization M would be proportional to the applied field. For weak field. So if the field is very weak, then the magnetization would be proportional to H. If the field strength is very large, if the external field strength is very large, then M need not be proportional to H. M can be proportional to H square or H cube, etc. Or okay. So if M is proportional to H, then the media is called the linear media. Okay. So this the definition of the linear and non-linear depending upon how the magnetization is related to the external applied field. So if the magnetization is just proportional to simply proportional to the H field, then the medium is called linear. Or such a response is called the linear response. The medium is linear. Otherwise, the medium is called nonlinear. So that is a simple definition between the linear medium and the nonlinear medium. So it is based on the response of the magnetic material to the external applied magnetic field. Okay, now we can introduce a proportionality constant here. So the proportionality constant M, the magnetization is equal to chi M times H. This chi M is called magnetic susceptibility. Okay. Now we know that in case of paramagnetic material, the magnetization would be along the direction of the applied field. Okay, so the magnetization would be along H. And for diamagnetic material, the magnetization would be opposite to H. So therefore, the chi M, the sign of chi M, depending upon the material. So if the material is paramagnetic, for paramagnetic, chi m would be positive, chi m would be greater than 0. And for diamagnetic, so positive, so this means positive. And for diamagnetic material, the chi m would be less than 0. That means it is negative. Okay. So if chi m is negative, then m would be proportional to would be in the direction of minus h. If chi m is positive, m will be along h. Okay, so this is one of the very simplest definition of this particular chapter, the linear media and non-linear media. Now, if you further look into this topic for linear media, okay, so we have already said. So for linear medium, I can, whether it is paramagnetic or diamagnetic, I can simply write m is equal to chi mh. Now, what is the relation between h and b? So if you can write b is equal to mu 0 times h plus m, because if you look at h is b by mu 0 minus m. Okay. Now, therefore, for linear media, I can write b is mu 0 times h plus m. I can write chi m times h. So this can be mu 0, 1 plus chi m into h. Now, this 1 plus chi m will call it as relative permeability. Mu 0, mu r, h. So I can write b equal to mu 0 mu r h, or b can be written as mu times h. Okay, so b and h is directly related. So b simply can write as mu into h, where mu is mu 0 times mu r, and where mu r is 1 plus chi m. Now, obviously, in case of vacuum, okay, what is meant by mu here? So mu is called permeability. Now, in case of vacuum or in free space, for free space, the magnetization is always 0. So since magnetization is 0, the chi m would be 0. And if you look at the mu for free space, it would be simply equal to mu 0, because mu r would be, because if chi m is 0, then mu r, which is 1 plus chi m, okay, it is already written here, mu r would be 1. So chi m 0, mu r would be 1, and mu equal to mu 0. So that is why this mu 0 is called the permeability of free space. And mu is called the permeability, or the absolute permeability, and mu r is called the relative permeability. Relative permeability. Okay. So that's all about the linear media. Okay, now for linear media, the b and h is directly related. The b is simply equal to mu into h, so there is no much of complication. Okay, so in case of linear media, the b and h can be used in equal footing. Okay, so there is not much difference. It is only differed by a multiplication factor mu. Okay, whereas for the other media, the B and H, we cannot write like this. There will be some kind of complication may arise. Okay, now finally, we can just look into the susceptibility, this chi m, for the different magnetic materials. So I will just show the table. So if you look at the diamagnetic material, so this is a susceptibility of a different diamagnetic material, and you can see the sign of the susceptibility is negative. Okay, so the bismuth, gold, silver, copper, water. Okay, so it is negative, and the order of magnitude. If you look into the order of magnitude, it is in the order of 10 raised to minus 4, 10 raised to minus 5, 10 raised to minus 6, and if you look at the hydrogen, it is 10 raised to minus 9. Okay, so the susceptibility is very small. It is in the order of 10 raised to minus 4 to minus 9. And for paramagnetic material, this chi m would be positive, and that is again you can see here susceptibility. It is positive. All signs are positive, but again the order of magnitude is very small. It is in the order of 10 raised to minus 6, and for only for gadolinium it is 10 raised to minus 1. Okay, so the most of the even the paramagnetic material, it comes very weak. Okay. Now, the other the important things we have to note here. So, since this susceptibility is very small, for most of the magnetic material, mu r would be approximately 1. Okay. So, this chi m, the chi m usually comes in the order of 10 raised to minus 6 to 10 raised to minus 9. Okay. So, it is very small quantity, and therefore, this mu r, which is 1 plus chi m, and it will be approximately 1 because chi m is very small quantity. 10 raised to minus 6 is 0.000001. Okay, so if you add 1 plus point 501, it will be almost equal to 1. Okay, so that's why for most of the magnetic material, this mu r we can treat as 1. Okay, but there are certain exceptions. So for some material that is not valid. Okay, mu r would be greater than 1 also, slightly greater than 1. But anyhow, this also slightly greater than 1, but it is almost negligible. This chi m is almost negligible compared to 1 if it is come in the order of 10 raised to minus 6. If comes in the order of 10 raised to minus 1 or minus 2, then it would be reasonably we can consider it. Anyhow, for most of the material, that is not the case that we have seen in this table. For most of the material, the order of chi m is very small. Only some material has having the order of 10 raised to minus 1 or 10 raised to minus 3. Okay, for those material, this mu r will be slightly greater than 1. Okay, so that's all for now. Okay, so with this, we have finished the discussion of the linear media and the non-linear media. So the linear media is a media with the magnetization is proportional to H. And what about non-linear media? So for non-linear media, the magnetization would be function of H. It can be any function. It would be H plus H square, or it is simply H raised to 1 by 2. Okay, so if the magnetization is function of H, where H can have any nonlinear power, any nonlinear order. Okay, so if it is not linear to H, then the material is called nonlinear. Okay, and usually the material shows the nonlinear property if the applied field strength is very large. Okay, so that is the most important thing. For a weak field, the most of the material shows linear nature, and if you apply very high field, then only the material shows the nonlinear properties. Okay, so with this remark, we are going to stop the discussion of the linear media and nonlinear media. So in the next class, possibly we'll discuss about the ferromagnetism and hysteresis. And these are the last two topics remaining in this module. Okay, so thanks for watching. We'll see in the next class. Bye.